Alright, today we're going to be doing another Pwnable.kr challenge. And the challenge that we're going to be doing today is going to be called Passcode. So, one of the very first things we do for this challenge is SSH in and put the password. So what I'm going to do is, since I'm already SSH in, I'll just go to the main folder where it's at, where everything's at. So I'll do CD right here, and I guess I'll just zoom in. And I think I'll just zoom in something like this so you guys can see it. So see the step ls, we giving 3 files. Pretty sure we can't just cat flag. Can't. So now we have a binary file, passcode. We see enter your name, so I'll just enter my name and then enter a passcode 1234. And then after that we get a seg fault. Pretty weird. And then we just check, I guess, the code. So cat passcode passcode.c. So get in passcode. Let's go check the main. So it's printing up today's toddler secret. Pass in welcome. Welcome is 100 bytes. Makes an array of 100. Enter your name. We enter the name. Enter the name of 100 bytes. And then after that, we it asks us to enter a passcode. And after that, it reads it in. Then it does a flush. Then it reads in another passcode. And I guess the passcode we need to enter is these two. That's what we're thinking. Right off the gate. So let's just try that again. Well, I think I'll just go down like this. Yeah. So if you do passcode, enter your name. I'll just put a bunch of A's. Enter passcode 1. So we're assuming is this one. So 338150. So 338150. And we get segmentation fault. And I guess we're asking, why is that? Why is that happening in our code? Well, the main reason with this, if you guys didn't notice, is if you guys never coded in C, is this scanf. Scanf is %d, and then it's this problem. This is the problem for the most part. Because if you look up what's on scanf, if you look it up, and then right here, scanfc. So with scanfc, the main thing is when you pass in scanf.c, let's gonna show this. Control plus scanfc. In this example, it has an integer like we do, but in this case, you enter the first number percentage d, and then it's a and sign with an a, or I think it's, I don't know what sign this is, but it's an and sign with an a. So what does this mean? So y and ampersand. Oh, I guess yd2 as well. So d is to accept the input of integers, so that's correct. That's what they got correct. But then we have y, the and sign. So while scanning the input, scanf needs to store that input data somewhere. To store this input data, the scanf needs to know the memory location of a variable, and here comes the ampersand to the rescue. Ampersand is also called as the address of the operator. For example, ampersand var is the address of the var variable. In our case, the ampersand, in this case, the ampersand value is getting the address of A. But in our case, there's no ampersand value. So I guess to fix this code, we need to add an ampersand value. But in our case, that's how the code was given to us. So that's how the binary is given to us without an ampersand. So whatever is placed at passcode, which is just something that's initialized randomly, is getting passed into passcode, even though it's not the actual memory address of it. I guess if I'm like whatever the physical value, because right now passcode, in passcode, in passcode, when you, I guess, initialize it, has like a random value at it. So I guess kind of show it off right here, like a online C++ compiler, or editor. So online C compiler. So we have printf. So I think if we just do something like this, so int a and then printf. This might not work. Printf a. And then if you just run this, printf. Percentage d. I kind of forget how C works. Then I think A. Yeah, I think that's how that works. And then run it. Oh, yeah, semicolon, and then run it. So 0. So it's passing in it as 0. So what does this mean? So you could think of it like scanf is right here. It's getting the memory address of A, but in our case, it's 0 if you didn't have the ampersand. So you need the address of the variable to pass in the values, but in our case, we're not using the address of the variables. We're literally just we're scanning in where the user input for passcode 1 is being passed in to like a 0. You can think of it, which is like somewhere that's like not in memory range, and that's where we're getting segfault, because it's probably a memory range that's like out of our control. So I guess the next question is, how do we solve this problem? So I was reading write-ups, and the way people, I guess, went about solving this problem, first they put it on GDB. So GDB and then passcode. And then we go info functions. We see a bunch of functions are given to us, but the main ones we're going to focus on are main, welcome, and login. And the main things we're going to focus on is main, welcome, and login. So what I want to do is disassemble main. So we disassemble main. We get puts, welcome, and login. So what we'll do now is enter welcome. So disassemble this as welcome. This as welcome. So we disassemble welcome. This is our welcome function. So we have printf. This prints out whatever comes out at the beginning of the welcome. So I think we go back up right here. Inside our welcome, this prints out enter your name. And then we have the scanf features. So we go to scanf right here. So we have scan printf. This just prints out whatever was at there. So then we go to scanf. So I guess if you guys don't know what assembly does, is when you do call scanf, you need to pass in the values. So these are the values you're most likely that's gonna get passed into scanf. We have EAX, EDX, and then lea. So what lea is basically, this is basically gonna pass in. If you just look up this instruction lea, this is basically a pointer to the address. So if we go look up lea assembly, what's the purpose of the lea instruction? Blah blah blah. It's the trick to do is the load effective address with sense support hello like Passcode C. So for the most part, you can think of it, it points to the address. So it points to an address. Yeah, yes, you can think of it, it's a pointer. Think of it like a pointer. And in our case, it's pointing to our array that we initialized. This is the base pointer, and I guess it initialized like a OX70 amount in between the base pointer. And after that, ESP is basically all the values being passed in right here. And if you guys want to be sure, I put it inside GoBall. If you guys don't know what GoBall is, it's basically a compiler for the most part, an online disassembler. In my case, I have enter your name right here with this right here. So when you scan F it, you see it's very similar to what we have for the most part. This one, yeah, EDI, RAX, and I think this one was EAX, but same thing. The EDX. Oh wait, it was EDX, but same thing. We use the lea instruction. It points it to there. So now this is a pointer to it. Now if you go back in our, I guess if we go right here, now we know that scanf is pointing to the array, which is what it's supposed to do for the most part. Now what we want to do is disassemble login. If we disassemble login, we see that we have the printf prints out whatever was in login. If we go back up, login is enter the passcode, and then we have the scanf feature. If we check the scanf feature, for the most part right here, we see that this is where our, I guess, we were able to input or scan in our integer value for the most part. And what we want to scan in is this. So this value is gonna hold our variable name, which is passcode 1. But this time, you can see that the instruction is different. And in this case, scanf. Oh my god, so much. In the scanf that we did beforehand, it has the move instruction. And if we go back up, this one has the lay instruction. So this is different. This is basically loading it in as a memory address pointer. Loading as a pointer, which is supposed to do. This is like it's the actual functionality of it. But in this case, this is not. It's using a move, so it's getting whatever literal value is at. Let's go. Oh my god, I might need to copy this. Sorry, I won't get confused. So I'll just copy this and copy. And then I think I have another one. Yeah, I have this right here. So exit nano solve.txt. And then I'll just make this bigger. Cat solve.txt. And then we just. So in this case, passcode 1 is using the actual move function, which makes sense because there's no address to it, so it's not pointing to an address. Well, this one's using a layout instruction, which is the right thing to do. So our next step is like, how do we solve this challenge? Like, what's the point of this challenge? So the point of this challenge is basically a GOT override. So if you guys don't know what the GOT is, you can think of the GOT as a way of it's a way of how the a C file, or like for the most part, and in this case I'm gonna explain it as a C file. How a C file is able to use a function like flush or printf or scanf. And I found an example here which is pretty good. Got overrides. So got overrides. So in this case they found a buffer overflow. And then they were able to overwrite the printf with a systems function, which is what, in our case, what we're going to try to do. And you guys could read this and look this up more for yourselves, but that's basically what we're going to try doing, or that's the whole point for this challenge. So if we go back right here, what we're going to do a got override on is on the flush. Reason being is because that's called right after passcode 1, which is kind of coincidence, yes or not, kind of weird. So what we're gonna do is fill up the 100, the array. We're gonna fill up the array, and then after that, we're gonna somehow overwrite passcode 1 with the address of flush, and from there, we're gonna be able to insert the address of system. Where is system? Scanf system. It's right around. Oh my god, I'm blind. System of Bing Cat. So it calls Bing Cat. I know it was a lot to, I guess, say for the most part, but I'll explain it for the most part. So you're saying how we're able to overwrite the I guess passcode 1. How do we overwrite this? So if we look back up, oh my god, I think I took it out. Oh no, it's gonna be my other one. So it's probably this one. Yeah. So if you guys don't know, if you see right here in our because welcome and login, they're like right next to each other, right? You see right here, welcome and login, and welcome, and then right here, you see right here, passcode. They're like, they happen like right next to each other. So what happens with the stack is that the stack is being reused for both of these, which is pretty weird. Pretty like I was a little bit confused, but I was reading more into it and I guess understood it a little bit. And what happens is that if you look at the disassemble, I'll just redo this again. This as welcome. Oh, do I not have? Oh, GDB passcode. This as welcome. If you look at this as welcome in the layout instruction, you see that the base pointer saved up OX70, which is, if you look at Kali Python OX70, which is a value of 112, right? So this is part of our array. So we know that. Now, if we check the value of this as a login, we see that scanf ex right here, EBP saves up, allocates OX70 of space right here, and right here layers EBP same thing, but this one's OX70, this one's OX10. If we look up OX10, that's basically OX10 16, and if we do 112 minus 16, that's 96. So from 96, so I guess what I'm trying to explain is that we have an array. I guess I'll just make this bigger. We have an array. We have an array of 100, but that array gets reused in the login feature. And in the login feature, since passcode 1 is initialized randomly, it was inside this array 100, and the last 4 bytes of the array is basically the last 4 bytes of the 100-bit array is the address of passcode 1. So what we're gonna try to do is basically overwrite passcode 1 to point to flush, and when it calls scanf %d when it calls scanf passcode 1, this is basically gonna be the address, oh my god, the address of flush. And from there we basically we scan in, but this time we're not gonna this time it's gonna call scanf but with the address of flush, but then we're gonna overwrite it with the value of system cat, and then after that system cat is gonna get called in. And I know it's a lot, but I guess I'll show you guys how this works. So if we go back right here, clear cd, I guess I'll do gdb. This is gonna get difficult. I have the code right here, but calling gdb from right here. Yeah, just go cd tmp working. I guess I show off my code. So nano solve.py. So right here we send line, we send 96. We got this from subtracting the 2 values that we found initially, and after that we send in the address of flush, the got address of flush. Now how do we get the got address of flush? So if we go back to cd this initially and we do gdb passcode, and then we do this sass flush because we know that's a info functions, and then flush plt. So we do this sass flush plt, or I think it's like this. This sass use flush. So if we disassemble flush, you see that it's getting point to a random it jumps to a random variable, and this random variable is basically the got. It's basically the address that we're gonna use later on in our code. Or I think I basically just copied because I did this problem like a way back, so I'll just basically just go back to what I have instead of moving back and forth. If I go right here, go to Passcode.py. So I guess if we put these back like right next to each other, I think this one's good. Yeah. If I put it right next to here, we got the got address for flush. So now we got the got address of flush. So you see right here, jumps matches to this. This is basically the got address of flush, because in the got table, like I was saying before, it's how a binary is able to communicate with is able to, I guess, jump to run the specific function. In our case, this basically just jumps and runs the flush command. But in our case, we're gonna grab this address, and we're gonna in this address. And I guess what I was trying to explain is that now that we overwrote the last 4 bytes, which now hold the value of passcode 1. If we go back to cd temp working nano solve.py, this is basically gonna turn our next scanf. I'll just comment this out so our code could work. Our next scanf, which is basically %d passcode 1. That's basically gonna become scanf %d, then the address of this, because when you, like I was explaining beforehand, when you this is gonna be the, I guess I'll just write it manually, A804 A004, because beforehand it was written like this, and then int passcode 1, that was basically a random variable initialized. But now that we filled up the entire random variable it's basically the last bytes of the array of name. It was the last bytes of the array of the name. So now and right here we changed the last 4 bytes to it, so it could be the address of it. So now passcode 1, except for pointing to like whatever was the last 4 bytes of the array of name, now it points to this. Now from there, scanf, what it's gonna do is gonna overwrite the flush command. We're gonna overwrite the flush command to system cat flag, which is what we're trying to do. So now from here, what we're gonna do is overwrite that. So from there, we're gonna send in the address of system cat flag. So if we go, I guess I'll show you guys how to find the address of system cat flag. So if we go to cd and then go to this right here and gdb passcode info functions. Oh wait, this as login. Then we should see login system being called right here, and it's calling this. So if we just do info functions this as system, this is the address of system that we're gonna use beforehand. I think this is the one that I used, and I just quit this and just to be sure. Used, I guess, a different value. We use 845D7C and 845D7C. Let me find out where I got this from. I have it in my notes somewhere. Oh, I got it from right here. Oh, I guess because for the most part, this is basically gonna set up our 84504 804085 DC. I wonder if I could put this one. Yeah, no. Oh no, this is where it starts because it ESP move. Yeah, so it'll be this is where I guess our value starts for the most part, right? Yeah, so this is, I guess, where our value of system gets started. So what we'll do is just basically, for the most part, insert that value right there, and then after that, address a system cat flag. And then if we just run this Python 3 solve.py, or Python, because yeah, this is like it's running an old version of Python, so I need to change it. So if we run this, we get login okay, and then bin cat no flag no such file directory. Now I can safely you have the credentials. And then yeah, that was about it for this challenge. I know it was a bit of a longer one for the most part, and I guess also to explain, because of partial reroll, that's why one of the reasons that we were able to do got overwrite. So if it was like if there was partial reroll or on, and that means we were able to, for the most part, or do got overrides basically, or yeah. Anyway, that was about it for this video. It's a pretty long one. Anyway, peace.